Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x times 20 minus 12x to the 2/3. The first thing to do is find the domain. F of x equals x, a polynomial term, the domain will be all real numbers, times 20 minus 12x to the 2/3 power, a fractional exponent. The denominator of a fractional exponent is the root. It's an odd number here, and the domain of an odd root is all real numbers. So altogether, the domain will be all real numbers, or negative infinity to positive infinity. The next thing to do is find all critical numbers. We will take the first derivative. F of x is the product of two expressions, so we'll make use of the product rule here. The derivative of the first term is a 1 times the second left alone, 20 minus 12x to the 2/3 power, plus the first left alone, x, times the derivative of the second, which is the power rule, bring down the power, 2/3. Leave the inside alone, 20 minus 12x, subtract 1 from the power. I will call that 3/3, and then multiply by the derivative of the inside to complete the chain rule. That's a negative 12. The first term, 1 times anything, is that same thing, so that will be a 20 minus 12x to the 2/3. In the second term, we can put the constants together. Everything's multiplied here. 2/3 times a negative 12 will be a negative 24/3, or negative 8. There is an x, and there is the 20 minus 12x to the 2 minus 3 negative 1/3 power. Since the second term has a negative power, we will need to rewrite it to give it a positive power. We'll leave the first term alone. In the second term, the negative 8 and the x are to a positive power, so they stay in the numerator, and the 20 minus 12x to the negative 1/3 can move to the denominator to become a positive 1/3. As soon as one or more terms in the first derivative have a denominator, we have to put all terms over a common denominator to get a single fraction for the first derivative in order to find critical numbers. We will need to multiply the first term, which has no denominator, by 20 minus 12x to the 1/3 power over itself, a form of 1. In order to get a common denominator to the second term, which is negative 8x, over that same denominator of 20 minus 12x to the 1/3 power. For the first term, we can multiply the numerators, 20 minus 12x to the 2/3 times the same base to the 1/3. We can add the exponents because of matching bases. 2/3 plus 1/3 is 3/3, or first power. So this will be 20 minus 12x to the first power. We can combine it together with the numerator of the second term, which is negative 8x. Because it is over the common denominator of 20 minus 12x to the 1/3 power. We can combine like terms in the numerator. 20 minus 12x minus 8x is minus 20x. And the entire thing is over the 1/3 power can be rewritten as the cubed root of 20 minus 12x. We want to fully factor the first derivative. In the numerator, there's a common factor of 20. Factoring that out, we'll leave behind a 1 minus x. In the denominator, the root is an odd root, so we can factor out a common factor in the odd root of 4, which will leave behind a 5 minus 3x. We now have the first derivative as a single fraction. All powers are positive. It's fully factored. We can set the numerator equal to 0 and the denominator equal to 0 and solve for all x's, starting with the numerator. 20 times 1 minus x equals 0. We can divide both sides by 20. 1 minus x equals 0, which means that x equals 1. And now working with the denominator, the cubed root of 4 times 5 minus 3x equals 0. We can cube both sides. Cube root cube will cancel each other out, and this will be 4 times 5 minus 3x equals 0 cubed, which is 0. We can divide both sides by 4, so 5 minus 3x equals 0. We can subtract 5 from both sides, so negative 3x equals negative 5. And we can divide both sides by a negative 3. The negatives will cancel, and that will give us a 5/3. We'll now check and see which of these are in the domain. The domain is all real numbers. X equals 1 is a real number. X equals 5/3 is also a real number. They're both in the domain. They are both critical numbers. We can now draw a domain line, a line representing the domain. It has no left end because it starts at negative infinity. It has no right end because it ends at positive infinity. We can put any critical numbers that we have found on here in order. 5/3 is bigger than 1, so 1 will come first. And then the 5/3. This will break the interval of the domain up into 3 separate intervals. We can pick a test value in each of these intervals. The first interval, negative infinity to 1, will contain 0. The interval 1 to 5/3, 1 is 3/3, to 5/3, the simple fraction in between there will be 4/3. And then 5/3 to positive infinity, we can pick 10. We can now test the trend by plugging these test values from each interval into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative. So the best place to plug into is the fully factored version. That would be this here. The 20 is always positive, so we don't have to worry about that. In the denominator, a cubed root, an odd root, can be positive or negative, so we have to keep it. And the 1 minus x can be positive or negative, so we have to keep it as well. Starting with the test value of 0, plugging into the portion of the first derivative that matters. 1 minus 0 is a positive number. In the denominator, 5 minus 3 times 0, which is 0, so 5 minus 0, which is a 5. 4 times 5 is a positive number, and the cubed root of positive number is positive. So the numerator is a positive, the denominator is a positive. A positive over positive is a positive. We have a positive first derivative, which corresponds to an increasing trend. Now we can plug 4/3 in. Starting in the denominator, 3 times 4/3, the 3's will cancel, and that will be a 4. 5 minus 4 is a positive, times 4 is still positive. The cubed root of a positive number is positive. In the numerator, 1 minus 4/3, 4/3 is bigger than 1, that will be a negative. A negative over a positive is a negative. We have a negative first derivative. This corresponds to a decreasing trend. Plugging in 10 to the portion of the first derivative that matters, starting in the denominator. 5 minus 3 times 10. 3 times 10 is 30, so that'll be 5 minus 30, which is a negative number. Times 4 will be still a negative number. Cube root of a negative number is negative. The denominator is negative. The numerator, 1 minus 10, is a negative. Negative over negative is a positive, and a positive first derivative corresponds to an increasing trend. So we have an increasing trend from negative infinity to 1, union, because it does happen again, from 5/3 to positive infinity. We have a decreasing trend happening from 1 to 5/3. Right at the critical number of 1, we have a trend change from increasing to decreasing. That means 1 will be a relative maximum. It has an x-coordinate of 1, and it has a corresponding y-coordinate that can be found by plugging that 1 into the original function. So y equals f of 1, which is 1 times 20 minus 12 times 1 to the 2/3. 1 times anything is that same thing, so it'll just be the 20 minus 12 times 1 is a minus 12 to the 2/3, and 20 minus 12 is an 8. 2/3 power means cubed root and then square the result. The cubed root of 8 is a 2 and then squared, and 2 squared is a 4. So this will be the y-coordinate for the relative max. Right at the critical number of 5/3, we have a trend change from decreasing to increasing. That makes 5/3 a relative min. 5/3 came from the denominator of the first derivative, and therefore it's not a normal relative minimum. It will be a cusp minimum. That always happens when it comes from the denominator. So we have a relative cusp min with an x-coordinate of 5/3 and a corresponding y-coordinate that can be found by plugging the x-coordinate into the original function. So y equals f of 5/3, which is going to be 5/3 times 20 minus 12 times 5/3, and the entire thing to be 2/3. So this will equal 5/3. 20 minus 12 times a 5/3 will be a, multiplying the numerators, a negative 60 thirds. So this will equal 5/3 times 20 minus 60 over 3 is a 20. And 20 minus 20 will be a 0. And 0 raised to any non-zero positive number is 0. Times the 5/3 will be a 0. So we have a corresponding y-coordinate of 0. So we have two increasing intervals, a decreasing interval, a relative maximum, and a relative cusp minimum. The cusp minimum on a graph is a minimum the tangent line goes vertical at it, and it'll look something like this, occurring at the 5/3, 0.